What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the number of positive real zeros or solutions, negative real zeros, and imaginary zeros using Rene Descartes' rule of signs, all right? And his rule basically just says the number of changes that you have from your signs over here is equal to the number of solutions that you have. And there's a little caveat here that says or less than by an even number. Okay, and I'll kind of explain a little bit more about that. So there's two things that we need to do here. So first we need to test f of x, and then we need to test f of negative x. Okay, so f of x is just how your problem is set up initially. So there's nothing you have to change. All you have to do is check the signs, all right? So let's start over here. So x to the sixth, right? As you can see, it is positive, right? So we basically go from a positive to a positive. There's no change there. Here we go from a positive to a negative. So there's one change right there. Here we go from a negative to a positive. So there's two changes right there. Here we go from positive to positive, positive to positive. Here we go from positive to negative. So that's our third change. And then that's where we finish, right? So here we had three changes, okay? So number of changes is equal to number of solutions. Okay, whenever we test f of x, this gives us the number of positive solutions, right? Because x over here is positive, right? So again, number of changes is equal to number of solutions. So here we would say that 3 changes is equal to 3 positive real solutions. Okay, but there's also this little caveat, right? It says or less than by an even number. So basically just 2 less. So we either have 3 positive solutions here, or we might have 1 positive solution here. Okay, it would be one of these 2 cases right here. Okay, the next thing we have to do is check f of negative x, all right? So now we're gonna just plug in a negative x wherever we have an x up here. So we're going to have a negative x to the 6th plus negative x to the 5th minus 3 times negative x to the 4th plus negative x cubed plus 5 times negative x squared plus 9 times negative x minus 18, right? Now we have to simplify this. So here we're going to get that f of negative x is equal to, let's see, negative x to the 6th power. Well, whenever you have a negative number or a negative variable raised to an even power, to an even exponent, it turns this positive, right? So negative x to the 6th is equal to x to the 6th, right? Positive x to the 6th. Here we have negative x raised to an odd power or an odd exponent, right? So whenever you have an odd power or exponent, that means this stays negative. So then this would stay as negative x to the 5th. So minus x to the 5th, okay? Here, negative x to the 4th, that would be equal to positive x to the 4th. And this times negative 3 is equal to negative 3x to the 4th, right? Here, negative x cubed is equal to negative x cubed. Here, negative x squared is equal to positive x squared, and positive x squared times positive 5 is positive 5x squared. And then here, 9 times negative x is equal to negative 9x, and then negative 18. Okay, so now that we've plugged in our negative x, now we have to check the signs. So here we start with a positive, right? And then we immediately switch to a negative, so we already have one change there. Here we go from negative to negative, here we go negative to negative, here we go negative to positive, right? So that's our second change. Here we go positive to negative, there's a third change. Here we go from negative to negative, so no change there, all right? So here we have 3 changes, okay? Now, when we're checking f of negative x, remember, number of changes is equal to number of solutions. So when we check f of negative x, this would tell us how many negative solutions we have, right? Because we're checking negative x, right? So then here we, again, had 3 changes. So this means we have 3 negative real solutions. Or, remember our little caveat, less than by an even number being 2. So 3 minus 2 again is equal to 1, right? So we either have 3 negative solutions here or we have 1 negative solution here. Okay, great. That was the brunt of the work. The last thing we have to do is just make a little table, and we're just going to list all our different possibilities of our solutions, right? So remember, we can either have positive solutions, negative solutions, imaginary solutions, and then here I'll make a last row or last column with the total number of solutions, okay? So we're just going to make a little table like so, okay? Now, the first thing I want to point out is if you look at the original problem over here, it's this one right here, right? F of x is equal to x to the 6th plus x to the 5th, right? Blah, blah, blah. Now, the main thing that you need to look at right here is the biggest exponent. So here is a 6, right? So this exponent, the biggest exponent on your polynomial, always tells you the total number of solutions, or zeros. So since we have a 6 here, that means we have a total of 6 solutions, or 6 zeros. So when we add up all of our solutions here, they should always add up to 6, okay? So for example, the first case we might have is we might have 3 positive solutions, right? So we might have 3 positive solutions, and we'd have to combine it with one of these, right? So we could have 3 negative solutions. So then how many imaginary solutions would we have? Well, we would have 0 in this case, right? Because remember, these have to add up to 6. So then we would have a total of 6 right there, okay? The other scenario we might have is we might have 3 positive solutions, right, with 1 negative solution, right? We might have 1 negative solution. And how many imaginary solutions would we have in this case? In this case, it would be 2, right? So then 3 plus 1 plus 2 is equal to 6, okay? Now the other 2 scenarios, and I'm going to make this a little bit longer. The other 2 scenarios we might have is we might have 1 positive solution, right, with 3 negative solutions. So in this case, how many imaginary would we have? We would again have 2, right, for a total of 6. And then lastly, we might have 1 positive solution with 1 negative solution, right? So then that would mean we would have 4 imaginary solutions here for, again, a total of 6, right? So these are all the possible combinations of solutions that we could have for this polynomial. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.